Good afternoon. I'm back here at Embedded World 2023, and I'm delighted once again to be joined by Brian Berner, who is the platform marketing for embedded processors at Texas Instruments. So Brian, thanks for joining us again.
Happy to be here, Paige.
So today we're going to be talking about new devices for vision processing. But before we crack on, can you just give us a brief introduction to yourself?
Yeah, so as you said, my name is Brian Berner. I am the marketing manager, or a marketing manager at Texas Instruments in the embedded processing business unit, focusing specifically on the hardware ecosystem.
Fantastic. And tell us a little bit about TI as a company.
So Texas Instruments, or TI, is one of the largest global manufacturers of analog and embedded semiconductors.
Mm-hmm. Fantastic. So you've had a lot going on this week.
Very busy, yes.
But to start off with, can you tell us a little bit about how you got started creating vision processing technology?
Absolutely, yeah. So going back into the TDA class of devices, we got our start in vision processing primarily for automotive. So things like ADAS, driver assistance, right? Driver monitoring systems, and going all the way up to surround view.
Yeah.
So yeah, at the booth, we have a good mix of automotive and industrial. But so the broader ecosystem primarily services the industrial market. So the automotive devices are where we put our DSP technology in, and that enables the vision processing the way we do it.
Fantastic. Okay, so let's start off with the BeagleBone AI or AI64. Tell us about the product.
Yeah, so you interviewed the BeagleBoard team.
Indeed.
And Robert, when they launched the BeagleBone AI64 back in June, so Embedded World 2022. And this board, it's kind of hidden underneath this beautiful heatsink, but at least it's not a fan. So that heatsink is obviously covering a lot of this interesting equipment. And so when you look at kind of the standard connectors, you have your FPC or flat flex connectors, CSI, so 2 connectors, but 4 lanes each, and then DSI and a lot of other stuff hidden on the other side.
Mm-hmm.
But we really wanted to take advantage in the ecosystem of those 2 4-lane CSI connectors and some other technology from Texas Instruments. So the V3 Link family is the industrial grade SerDes. So here you have a 4-channel deserializer right there. So you got the connectors coming in, and then you go to these 2 connectors. So taking full advantage of the throughput for those 4 cables. And so because a lot of this comes from automotive, you end up with these connectors that are very ruggedized. So you have to clip them in. So to drive the cost of development down, we looked at, well, how do we take this, bring it into an existing third party that has a lot of recognition in vision processing and adapter boards, and essentially allow you to do, in this case, 4 cameras that start out as a 15-pin CSI, convert in the backpack model, and then you have your connector over here that I believe it rotates, but I just broke it off. And so that connector then allows you to do all of this communication. So power is transferred over this as well as the data. So, right, so serial. So these are the serializers here. Once you really get started, then you can start looking at the camera module. So this one is from Technection. So it's native with the same technology. So you don't need the adapter, the little backpack, which is now damaged.
Yeah.
So you can start looking at the specific types of cameras you need for the application. Pick one. If it's already in this style, then you can connect it right out of the box.
Excellent. So what would you say then are the main feature highlights of this board and the multi-camera input accessory from ArduCam?
Yeah, so again, ArduCam has done a lot of these types of things. I think when we looked at what the options available were in terms of low-cost multi-camera or even multi-sensor inputs, what you end up with typically is something where you're doing multiplexing, right? So you're, like when we're all trying to not change from one screen to another and multitask, we're multiplexing horribly. And so you're losing that throughput. And so this serial connection, high throughput. So I think it's, here you have 1.5 gigabits per second per channel. So if you have 4 lanes, you have 2 channels. So here total we have 8. The interesting thing about this board is that we designed it to be stackable. So you can swap this guy here, stack it up, put it on another one, then you got 8 cameras in. So when you go potentially up to higher performance, you could do 12 cameras in.
Excellent. And you've also recently announced a new AM6XA vision processor family. Can you tell us a little bit about that and what it's made for?
Absolutely. Yeah, so we released a family of 3 new devices in the AM6XA family. So if you went over to our wall over there, you have the AM6-2A, the AM6-8A, and the AM6-9A. And so for those of you that speak in this language, it's 1 to 32 tops. So scalable performance from 1 to 32 tops. If you don't speak that language, this example's cleaner to me of 1 to 12 cameras.
Fantastic. And I understand that there is an iWave SOM based on this device. So can you tell us about that as well?
Yes. So the iWave SOM for the AM6-2A is right here. And so this is taking advantage of a standard form factor, the OSM-L. And so you have your vision processing capable device on there. You also have all the components needed to use it as a functional processor. And then you fan out all of the peripherals onto, in this case, the OSM standard has a compatible baseboard. It's compatible with all the sizes, right? So there's a couple like little blocks back there. So it goes from 0, which is kind of like a high performance MCU, up to S, M, and L. So L is the large size, but still not that large compared to some of the standard form factors that have edge pins. So this is a way to shrink it and take advantage of the flexible, scalable pin out. So we have some devices that are in the 6.2 family, which is our general purpose device. The Beagle Play that you saw earlier in the week uses the AM6.2. So you can run our Edge AI SDK on the A53 cores in that device, but you're using that processing power. You don't have a dedicated accelerator. So the AM6-2A adds that accelerator. So you can scale across modules. So this is just one example, and there's a few others where you can scale from the 6.2 to the 6.2A depending on your needs.
And which applications is this suitable for in particular? Yeah,
so I would think of this as, in the case of our demo, like a retail automation type of thing. So a grab and go stand at an airport or a cafeteria. So it can tell what you've put on the plate, ring up the total. So you see your receipt, all those items are in there, and then pay once everything's rung up. It'll also, in the case of 2 cameras, be able to do theft detection, right? So prevention. So yeah, using the tools that we have provided, GStreamer, OpenCV, then you can start developing for something like that pretty quickly.
Fab. And we also have the AM68A device. So tell us about that and its features.
Yes, so the AM6-8A is actually quite similar to the device that's on here. And so when you start thinking about the automotive driving the TDA development, automotive driving FPD link development, TDA became AM6 when we did this launch, and FPD link, which is pretty well known in the industry, is V3 link. So taking that technology that's been tested, tried and true in automotive, bringing it into industrial, and the example for Beagle board would be the BeagleBone AI64, also has a Beagle car. And so that's kind of your entry-level robotics, autonomous mobile robot, where you can get that whole kit for a very low price and start developing with things like radar, LiDAR, vision. So all that sensor fusion in a very easy to use development tool. So the AM6-8 introduces that same performance into industrial without the functional safety, Q100, all those additional certifications.
And I understand that there is a Phytech SOM based on this device. So can you tell us about that as well?
So we have the Phytech SOM here. We'll cover ArduCam for a second. They still exist. Yeah, so the Phytech SOM here for the AM68A, as you can see, it's a little bit larger, not dramatically larger, but you have these high density interconnects here, right? So taking advantage of the full peripheral set of the device, so PCIe, USB 3, so think of like a box computer with high throughput attached. And so then the camera's MIPI CSI 2 lanes are also pulled out to the baseboard, and you can start developing very quickly. So our friends over at Phytech, I can see one of them there, they had this board, you know, very near to the show, right? And they were essentially using our release candidate SDK, developing with those tools, but they had the same demo running at their booth, single camera input, but it measures the performance, the loading on the CPUs or the A72 cores, the loading on the DSPs. So pretty easy to get started. Object detection. I think the demos, like, is it an apple? Is it a banana? Right? Not necessarily that advanced, but when you start thinking about the number of things that you can detect very quickly, then you can start doing some analytics on people, people counting, you know, where are people looking. So the models can get more complicated than the standard pretty quickly. Yeah,
I mean, that was what I was going to ask, you know, what sort of applications are we looking at with this one? So object detection then.
Exactly. So object detection, I think of kind of like your box PC. So we'll get to this one in a minute, but your box PC that has a bunch of inputs. Some of them are USB 3. Some of them are expanding the PCIe into other formats. PCIe is a good example of, you can take that mini PCIe and convert it to a wireless module, and then encode the data and send it over wireless and process it somewhere else. But so you can do a lot of edge processing here, but display it somewhere else.
Fantastic. So can you tell us what your software development environment looks like for the new AM6X8 family?
Yes. So I will tell you that as soon as I tell you about this one.
Yes.
And this one is the other one in the family, the 6.9A. And so that scalability is that 1 to 2 cameras. So the 6.2A, the retail automation, the 6.8A, kind of like a box PC, and then the 6.9A. Now this looks like a box PC, but it is actually the very, very high performance version of the Beagle car using that, right? So you take a module using the AM6.9A, a scalable module inside, so you could actually choose 2 operating points and put it in this box. And so the front that you're seeing, I don't know what order they're in, but the same connector style is used on here, but this is 1 channel. And so there's 2 by 4 in there, so you can get 8 in a nice clean way. And then on the bottom, you have a technology known as single pair Ethernet, which is quite popular today. And so the technology of V3 link is up to 15 meters, very high throughput SerDes. And then the SPE, or single pair Ethernet, is used in a lot of factory automation applications today. So there's a demo over there showing vibration monitoring. Another technology that recently came from automotive. It was actually called Ethernet for automotive for a period of time. And so that is single twisted pair over very long running wires. I think the first time I saw it, it was like, take it out of the TI office in Dallas, run it all the way through the parking lot, you know, out to the DART station, or Dallas Transit, and it can run that distance. So the not the throughput, but the bandwidth, it depends on how far you're going, the voltage that you need to deliver to the other end. But just as a great example, so if you think of sensor fusion as cameras need a lot of throughput, but some other things like radar, other sensors that are using less bandwidth would potentially connect to the single pair Ethernet and run longer distances.
Fantastic. So talk to us then about your ecosystem. Does all the hardware and software from development come from TI?
Yeah, so what I didn't bring, because I love the ecosystem, is our starter kits. So our starter kits are the SK devices. So the demo that we have over there shows the SK-AM62A, the SK-AM68A, again, SK-AM69A. And so you have those initial tools to start developing from TI. In fact, you can actually use those EVMs or starter kits in the cloud as well. So we have our Edge AI Studio. So you can start evaluating the performance, running your favorite models, your favorite algorithms through the models that people are familiar with. So TensorFlow Lite is the one that I think most people are more familiar with, Onyx being another one. So you can run your inputs through those models on real boards, or you can buy one because we try to make them as low cost as we can.
So following on from that then, what does someone need to start building performance optimized embedded applications using these devices?
Absolutely. So you could get an SK-AM62 and start developing a single camera with one of these guys, not that, one of these guys right here. So you can connect it directly to the board. And so that's the IMX219 camera from ArduCam. So you can connect that directly to the board, out of box, start doing object detection, facial recognition, pose estimation. You can actually do it with the video loaded on like a USB drive. And so that's how we do the demo on the wall and then use these as an example. A lot of people, when they get started developing for vision processing, they're either using Ethernet or USB. And so when you take a camera module like that, you do the image processing or the ISP at the camera module itself, and then you convert it to a standard interface, send it over, and do the processing. So when you do this type of CSI direct input, you have to have the ISP on the chip to make it optimal. So you have the ISP front end, and then the DSP for the vision processing, and then the CPU or GPU. So when you combine all those things together, that's what people typically call a heterogeneous SoC. Typically there's some MCUs in there for getting fancy with like safety type of applications.
Excellent. And all of these starter kits and third-party modules are sampling now? You know, where can people go to learn more?
Yeah, so the easiest place to go is ti.com/edgeai.
Okay. Simple.
It's that simple. Yeah, you thought it was going to be a longer answer.
I know, it's easy. Fantastic. Well, thank you so much for bringing all these along to demo.
Of course.
Even though you broke one.
He's not going to be happy about that. He's out there somewhere. He carried it over here and I broke it.
It's fine. You won't be in trouble. Anyway, thank you so much for your insights.
Thank you so much.
As
After
always.
3 days, our voices are finally gone.
Thank you.